So this is me, and I'm planning a trip. I first want to stop at the garden. You see it nice and pretty? So I need to travel to the garden. So watch how I'm going to travel to the garden. I'm going to have to move 1, 2, 3, 4 spaces to my right. And then I'm going to have to move 1, 2 spaces up. So that is 4 places along the x-axis in the right direction. So that's a positive 4. And 2 spaces up along the y-axis. So that would be a positive 2. So to represent my journey from where I am right now to the garden, I could simply take a vector. And the vector would be this line from where I am going to the garden. So notice I'm starting from this point and I'm going towards the garden. So I start here and I'm traveling this way. So the vector that will take me from this point to the garden would be 4, 2. Now, let's say I am at the garden. Now I want to go to the wonderful, wonderful Blue Mountains. So, at the garden, I need to move 1, 2 spaces to the left. Now going to the left is negative. And then I need to move some spaces up. 1, 2, 3. So to move from the garden to Blue Mountains would be represented by this line. Let me put it in. From the garden and going to Blue Mountains. So I started at the garden and I'm traveling to Blue Mountains. So wherever I'm going to, that's where I'm putting my arrow. So the vector that would represent my movement here would be a negative 2. And then I had to go 1, 2, 3 spaces up. Good. Let's say I want to travel home now to the point that I originally started from. Notice I'm at Blue Mountains now. So I want to travel right back home. So to do that, I have to move on the x-axis first. 1, 2. So notice that is going towards the left. So that would be negative 2. And then I'm going to have to come down now. 1, 2, 3, 4, 5. And I'm going down. So that would be a negative 5. So the line that would represent this journey from Blue Mountains to my original starting point would be this. So remember, we started from Blue Mountains and now we're coming right back home. So the vector that would represent this movement would be negative 2, negative 5. And this is what vectors are important for. They help us to move things. They help us to get around from one place to another place. And when I think about it, even this video was created using vectors. When you see the picture, them start flying and all things like that. And we use vectors too to create moving pictures like animations. You know those animes that you really love watching? Yeah, man. It's some wicked vectors them use to get those things to move. Alright, so notice a vector is a sense of motion, moving from one point to another point, from one point to another point, and from one point to another point. So this vector, it has a sense of motion, and notice that it's going into different directions. So I could simply say that a vector is a sense of motion that has size and direction. And this is one way that we can write a vector in column form, with the horizontal shift, the X at the top, and the vertical shift, the Y movement, right down here. This is what you call a column vector, with the horizontal shift, or your movement along the X-axis first, and then your movement along the Y-axis second. We could be asked to represent a vector graphically. So here they're asking us to represent the vector 2 minus 4 graphically. So I know that X will be my first movement and Y would be my second movement. Now you have to pay close attention. So the X is positive. That means I'm going to be moving to the right. If it was negative, I would move to the left. So I need to move to the right 2 spaces, right? So I could pick a point here, any random point, and move to the right 2 spaces. So I could go 1, 2. Then now I'm going to worry about my vertical shift, which is represented by the Y. So it is a -4. Negative means that I'm going to go down if I'm working with the Y shift, the vertical shift. So remember, Y goes up and down. So because it's negative, we're going to go down. But how many spaces? 4. So from here, I'm going to go down 4. 1, 2, 3, and 4. So I would end right at this point right here. So I would start here and use my ruler to end here. And if I'm starting here and ending here, that means the movement is like this. So I will put an arrow here to show that the journey is from this point, starting at this point and ending here. This is what you would call the tail of the vector. And this is what you would call the head of the vector. Simple. And the opposite is true. We could be asked to use this graphical method, or from this graphical representation, to write a column vector for the vector A, B. So notice we should be starting at A and heading towards B. So I'm going to start at A, and I'm going to count how many spaces horizontally first that I need. So to get to B. So this would be 1, 2, 3. And seeing that I'm moving to the left, it would be a -3. I'm going to reach B yet. I have to move up 1 time. So to represent A to B as a column vector, it would be -3 from a horizontal shift and a +1 from a vertical shift, because I only went up once and I went to the left 3 times. Use my brackets, and that's it. This is how we would represent this vector A to B in column form.